today I'm gonna explain the introduction of our mini project on embedded system. So the introduction are the sunlight notification alarm system is a mini embedded system project designed to detect the presence of sunlight and notify the user using both visual and audio indicators. The main goal of the project is to provide an alert when sunlight reach a certain intensity, which could be useful in application such as greenhouse monitoring or early morning wake-up alarms. This project helps students to understand sensor integration and analog signal processing and basic output control using microcontroller. So I'm gonna explain the input and output component. So it's just a simple mini project, which is we are using light dependent resistor, which is LDR, used to detect the presence of intensity of sunlight. So it will detect sunlight resistor. And then the output component is buzzer for sounding an alarm when sunlight is detected above a threshold. And then we also have LED lights up to provide a visual notification along with the buzzer.
Today I'm going to present about our circuit and then our code circuit diagram and then our coding for our mini project. Alright, let's break it down step by step, starting with the circuit diagram, then the code. First is the circuit diagram explanation. So this is a basic LDR light dependent resistor, which is a base light detection system using PIC 18F4580 microcontroller lah. And component and connection are just like below. LDR1 connected to the RO/ANO pin 2 for the PIC, and it's act as the light sensor. Work with a voltage divider using a 10K resistor, we call it as R1, to provide an analog voltage based on light intensity. And for the microcontroller U1 is PIC 18F4580 to the pin 2 RA0/ANO is configured as an analog input for the reading the LDR value, and for the pin 15 RC0 connected to the LED D1, and pin 16 RC1 connected to the buzzer, buzz 1. And for the ground and power connection is already proper connected. And for the LED, for the output, is connected to the RC0 pin 15 and it's turned on when the low light is detected. For the buzzer, it is connected to the RC1 pin 16. It activates simultaneously with the LED in a low light. Alright, and next let's go to the code explanation. For the code explanation, the codes read analog value from the LDR and control an LED and buzzer based on the brightness level. So let's break down the code. First, we have the definition, or we define. As you can see over here, there's hashtag define XTAL frequency to 200,000 and all of that is set oscillator frequency. It is for define the LED and buzzer for easier control of the RC0 and RC1. Next is the ADC installation, which we have the void ADC integer addcon 1 until addcon n0. It is configures analog pins and set ADC operation mode, and the RA0/AN0 is enabled as analog input. Result is tried justify with acquisitions time and conversion clock set. And for the ADC reading function, we have the unassigned INT ADC read, unassigned char channel, and everything over here. It is selects ADC channel lah. We start the conversion. It is wait for conversion to finish and return the 10-bit ADC result. And for the main function, we have the void main void, which is we have the trees A, 3 C bits, trees C bits, trees C1. We have the LATC and all of that. Until the buzzer equal to 0. The RA0 is input and RC0 and RC1 are the output lah. Constantly reads the LDR value. If the light level is low, then which in bracket ADC is lower than 600, then it turns on the LED and buzzer. Else, turn them off. Alright, that's all. So for summary, this project used the LDR to detect darkness. When the light level drop below a threshold, which is the 600, the system turn on an LED and a buzzer as an alert system.
For the observation, when the system is exposed to bright sunlight, the LDR detects the high light intensity, resulting in a voltage drop that crosses the predefined threshold. This triggers the microcontroller to turn on both the LED and buzzer simultaneously. When sunlight is not present or below the threshold, both outputs remain off. This simple feedback mechanism allows real-time monitoring of light condition. Next, we move to the cost estimation. This the all component that we need. First, for one LDR sensor costs 50 cents per each. Buzzer 1 ringgit per each. LED for one LED is 20 cents. For two resistor 20 cents. Arduino board 5 ringgit. And breadboard and wires 3 ringgit. For total cost of all these components is 9 ringgit 90 cents.
Now benefit. This project offers an easy to build and low cost solution for sunlight detection. It helps user automatically respond to light change without constant monitoring. The system can be used in various applications such as smart windows, agriculture, and home automation, making it a practical learning project for understanding basic embedded systems. Last but not least is objective. There are 3 objectives, which is to detect level of sunlight, to notify and give alert to the users, and to implement embedded system in our mini project.